Hello friends, welcome to Maths Practice. Today we are going to discuss Arithmetic Progressions or AP. It is the fifth chapter of class 10. Arithmetic progressions will be discussed thoroughly, so do watch the video till the end. And please don't forget to subscribe to my channel Maths Practice. What is an arithmetic progression? You must have seen a series of steps leading to a temple or a monument. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. Now the first step to the temple starts from the ground obviously. Every step is at 15 centimeter rise from the each previous step. And suppose if there are 50 more steps, then one has to climb 15, 30, 45 up to 750 centimeter. The meaning is the distance between the two steps is same and you have some number of steps which leads to the monument. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Now this fixed number is called the common difference and it can be positive, negative or 0. You can also go down like you go up. Examples of AP are 100, 80, 60, 40. Now you can see over here the difference is minus 20. You have the next one 1, 3, 5, 7. In this 3 minus 1 is 2, 5 minus 3 is 2. So here the common difference is 2. 5, 5, 5 and so on. In this series the difference is 0. Another example is minus 1.0, minus 1.5, minus 2.0 and minus 2.5. Here also you have a common difference. Let us see some other examples of an arithmetic progression to get a clear idea. The first to fifth cash prizes given in a competition are $250, $200, $150, $100 and $50. This is an AP because you have the common difference, which is $50. But if the prices are given in this order, say $500, $400, $350, $250, $150, then it does not form an AP because the difference is not the same. The minimum temperatures in degrees Celsius of a city are recorded for the week of January arranged in ascending order. Suppose they are minus 3.1, minus 3.0, minus 2.9. It is an arithmetic progression, correct? Because the difference is same. If A is the first term and D is the common difference, the terms of the AP are A, then A plus D, A plus 2D and so on. This is called the general form of an arithmetic progression. Now we can have finite arithmetic progression or you can also have infinite arithmetic progression. Example of infinite AP is the list of all positive integers starting from 1 whose common difference is 2. Then I can say that 1, 3, 5 and so on is an infinite arithmetic progression as it does not have a last term. In general, you can have a finite or an infinite arithmetic progression, and in general for an AP, A1, A2, AN are the terms. Then we have the common difference D, which is the difference between two terms. So AK plus 1 minus AK means D is equal to the difference between the K plus 1 term and the Kth term. Example 1. The bus fare is 15 rupees for the first kilometer and thereafter 8 rupees for each additional kilometer. Then the AP will be 15, 23, 31 and so on. The amount of money in the account every year when suppose 100 rupees is deposited at compound interest at 7% per annum. Now this is not an arithmetic progression because for compound interest the principal amount for the second year will be 100 plus 7 which will be 107. So every year the difference will not be the same. For an AP 1 upon 3, 5 upon 3, 9 upon 3, we can say that the first term is 1 upon 3 and the common difference is difference between the two terms 5 upon 3 minus 1 upon 3 which is 4 upon 3. Similarly 9 upon 3 minus 5 upon 3 will also be 4 upon 3. Also minus 1.2, minus 3.2, minus 5.2. This is an AP with the first term minus 1.2 and the difference will be minus 3.2 minus 1.2. So it will be minus 3.2 plus 1.2, which will be minus 2. D is the common difference between two successive terms. 3 plus root 2, 3 plus 2 root 2. This is also an AP with the common difference root 2. But if we have 1 square, 3 square, 5 square, it is not an arithmetic progression because obviously the difference is not the same. The first four terms of the AP with the first term A as minus 1.25 and the common difference D as minus 0.25 will be, first term is minus 1.25, then we add minus 0.25, so it will be minus 1.5, minus 1.75 and so on. How to find the nth term of an AP? The nth term of an AP with the first term A and the common difference D is given by An is equal to A plus n minus 1 into D. This is an important formula. An is also called the general term of the arithmetic progression, and sometimes the last term of the arithmetic progression is also denoted by L. So An is equal to A plus n minus 1 into D. This gives the nth term of an AP. Example, determine the AP whose third term is 5 and the seventh term is 9. A3 is the third term. A3 is A plus 3 minus 1 into D, which is equal to 5. So we get the equation A plus 2D is equal to 5. Seventh term is 9, means A7 is 9. A7 is A plus 7 minus 1 into D, which is equal to 9. So we get A plus 6D is equal to 9. Now just solving the equation, subtracting the first from the second one, we get D as 1 and A as 3. So the required arithmetic progression is having first term 3, common difference 1. So it is 3, 4, 5, 6 and so on. Another example, check whether minus 150 and minus 61 are terms of the arithmetic progression 11, 8, 5, 2 and so on. We can see it is a decreasing AP. The first term is 11 and the common difference 8 minus 11, 5 minus 8. So the common difference is minus 3. Now we are given that minus 150 is a term. So An is minus 150 for some n. An is equal to A plus n minus 1 into D. Minus 150 is equal to 11 plus n minus 1 into minus 3. Solving this, we get n is equal to 164 by 3. But n is the number of term. So n should be a positive integer, which is not true over here. So minus 150 cannot be the term of the given AP. N is not an integer, so it will not be a term of the given arithmetic progression. But suppose if you have minus 61. Minus 61 is equal to again A plus n minus 1 into D. A is 11, D is minus 3. Solving this, we get n as 25. So we can say minus 61 is the 25th term of the given arithmetic progression. Example 4. How many 3-digit numbers are divisible by 7? Now 3-digit numbers divisible by 7 will start from 105. Because we know that 100 up till 104 will not be divisible by 7. 105 is divisible by 7. After that, the common difference will be 7. So 105, 112 and so on. The last 3-digit number divisible by 7 would be 994. So now this is an AP with the first term 105, common difference 7 and the nth term as 994. According to a formula, An is equal to A plus n minus 1 into D. 994 is 105 plus n minus 1 into 7. Solving this, we get n as 128. That means there are 128 3-digit numbers which are divisible by 7. We have seen how to get the nth term of an AP. Now the sum of the first n terms of an arithmetic progression. The sum of the first n terms of an arithmetic progression with the first term A and common difference D is given by Sn or S equal to n by 2, 2a plus n minus 1 into D. This is an important formula. S is equal to n by 2, 2a plus n minus 1 into D. We can write it in another form. A plus n minus 1 into D is an. So S can also be written as S is equal to n by 2 A plus an. Suppose if we denote an the last term as L, then S can also be written as S is equal to n by 2 A plus L. Also, the nth term of an arithmetic progression is the difference of the sum of first n terms and the sum of first n minus 1 terms. Means Sn minus Sn minus 1. Some important examples. If the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. It is given that the sum of the first 14 terms means S14 is 1050, first term is 10. Now we know the formula S is equal to n by 2 2a plus n minus 1 into D. S14 is 14 by 2, n is 14 over here. A is 10, so 2 into 10 plus 14 minus 1, that is 13, into the common difference D, and this is given as 1050. So solving this equation we get D as 10. So now to find the 20th term, we already know nth term is found by an is equal to a plus n minus 1 into D. So a20 is 10 plus 19 into 10, which is 200. So the 20th term of the AP is 200. Example 6. How many terms of the AP 9, 17, 25 and so on must be taken to give a sum of 636? That means we want the sum as 636. The first term is 9, a is equal to 9. Common difference is 17 minus 9, which is 8. We have Sn as n by 2 2a plus n minus 1 into D. 636 is equal to n by 2 18 plus n minus 1 into 8. So we will now have a quadratic equation for n. The quadratic equation reduces to 4n square plus 5n minus 636. We factorize it, which gives the factors as n minus 12 and 4n plus 53 is equal to 0. Equating the factors to 0, we get n is equal to 12 or n is equal to minus 53 by 4. But we know that n is equal to 12 is the only possible answer because the number of terms is always a positive integer. Hence 12 terms of the AP must be taken to give a sum of 636. Next example. 520 logs of wood are arranged in such a way that the bottom row contains 45 logs. Number of logs goes on decreasing by 2 in a successive upper rows. How many rows are there? What is the number of logs in the top row? And can you arrange 225 logs in the similar way? Now what is given is 520 logs are arranged and the bottom row contains 45 logs. So 45 is the first term. After that you arrange one by one in different rows. First term A is 45. The common difference is minus 2 because the number of logs goes on decreasing by 2. So the common difference is minus 2. Now we have to find n for which Sn is 520. So Sn is 520. Sn is equal to n by 2 2a plus n minus 1 into D. Putting the values, we get a quadratic equation reducing to n square minus 46n plus 520 is equal to 0. N square minus 46n plus 520 equal to 0. We find out the factors of 520, which gives the sum as 46. So n square minus 26n minus 20n plus 520 is equal to 0. We get the factors as n minus 26 and n minus 20. Equating to 0, n is either 26 or n is 20. Now suppose if n is 26, the nth term formula is an is equal to a plus n minus 1 into D. So a26 will be equal to minus 5, which is obviously not possible for the number of logs. So n is equal to 26 is not possible. If we put n is equal to 20, we get the 20th term a20 as 7. Hence this means that there are 20 rows, n is 20, so there are 20 rows and the number of logs in the top row is 7. Similarly for 225 logs. Now we know that if 225 logs are there, we can arrange as 45 plus 43 plus 41 plus 39 plus 37 because the common difference is -2. This sum is 205. We have 225. So additional 20 logs would be placed in the top row. But if we place additional 20 logs, the pattern will not continue. So 225 logs cannot be arranged in the above pattern. Even mathematically for 225 logs, 225 is Sn. Sn is equal to n by 2 2a plus n minus 1 into d. So we get Sn as n by 2 90 minus 2 into n minus 1. Solving this quadratic equation as we have done before, we have the quadratic equation n square minus 46n plus 225 is equal to 0. Now we know how to solve a quadratic equation. We first find the discriminant d. Here the value of d is 1216, which is not a perfect square. So we will not get a rational number for n. So from this also we can say that it is not possible for us to arrange 225 logs in the similar pattern. Hope the concepts of arithmetic progressions are clear with the help of examples. In the next video we will discuss some other important examples for arithmetic progression. So please do like, share and subscribe to my channel Maths Practice.